All right, everybody. Welcome to this tutorial. The reason why I'm doing this is because some of you in the class asked me about modifying the pose classifier example in order to have more detail, for example, like gesture recognition. Um, so the example that we're going to do today is somehow like a free live coding. So probably some things will not be optimized. Some things could be like written in a different way. But yeah, just bear with me. I will try to keep it detailed and super pedagogically well explained while trying to actually do this in a fast way. Like hopefully like under 30 minutes. That I think is going to be a little bit hard, but let's try. So the first thing, as you see here in that part of the screen, we're in Visual Studio Code, and we will just start from so we will start with like the just like the configuring like we will start from the boilerplate ML5, meaning that if you go to the website and if you download or if you check the boilerplate implementation of this, you will find an index.html, and that one has basically it's this, right? It's importing v5 and also importing the latest version of Visual Studio Code. So here, the line that I'm just highlighting now. And we will do also like this hand recognition. I had these files not coded with hand. So I already configured that before. We will call it hand recognition. And we need to prepare a couple of things. The first thing that we need to actually do is enable, right? And we will borrow heavily from the hand pose example on ML5 to implement the hand pose. So first we will start by declaring our variables and parameters. Some will be initialized, some not. So the first thing that we need, if I remember correctly, is the model for the hand pose. So we will call it hand pose. Let me do this a little bit bigger so you can actually see it. This will be hand model. We need also a video. Yeah, for video this is all we need. So let's do a setup function, setup, and the setup will be something like this. We need to, of course, initial settings such as create a canvas. The typical is 640 comma 480. We need also establish a video. So for that we do video equals to create capture, and we pass the video element to it. What else do we need? We need to establish also the video size, and that will be width and height, and we need to initialize actually we need to create a hand model, right? We need to say that hand pose equals to in this case is because we're using ML5 not TensorFlow.js, ML5 that hand pose, and the parameters that we need to pass to this function are our video, and also we can add is good so we know that everything is working. a callback function that we will call video ready. So we can put it here, video ready, and he'll say console.log something simple like model is ready. Simple. Once we have the hand pose model created, what we want to do is actually start already like capturing hands, right? Start detecting hands, and for that we just say hand pose on, and we do predict, and here we can say like results, and we can use the arrow function here, saying that our results, we can say something like predictions equals results. But we don't have predictions declared, so we need to actually declare that. So we will say here let predictions equals to that. So now that we have this, we want to also hide our video, because we want to render our video in the draw function. You know, like typically like P5 or processing, they have this two functions. Setup is the one that you set at the beginning, the first frame of your app, and then the draw is the one that basically executes at every frame. How fast? As fast as your machine is. You can of course configure that, but we'll say like video 0 0 width, height, we will say like if no, we will say just this, right? So if we want to see if the hand is actually like if we're getting, you know, the classified hands, we can do something like we can call the function draw hand and say let me see how we can do this in a fast way. Yeah, we can do like, again, I could open like the code from ML5, but let's do how it goes here. So it probably will be like a pretty, if not equal, just the same code for that part. If I remember correctly, this was we need a for loop, right? I equals 0, where I is less than here predictions dot length, because basically here we're gonna see if we have a prediction. In this case, you need to remember that the hand pose model from ML5 can only let you draw one hand at the time. It doesn't support multi-hands, so we will do that. So if we get a prediction, we will say like here like a constant prediction equals predictions, and we will get that predictions, and we will say here, I'm going to use this, change this for J. We will say that now for every prediction, then landmarks that length, so one parenthesis here, let me format the code. So again, we are checking if we have a prediction. If we have a prediction, because we will only have like one prediction, we will get that prediction, and we will check the basically what returns the hand pose model returns are three things, at least three things. The bounding box of the hand that we will use later. It detects the landmarks, those are the key points, and other parameters that I don't remember very well. But in this case, the landmarks are useful because we can say like key points, and we can say, for example, prediction that landmarks at J, and here we can just like draw whatever we want, right? We can say like fill, now file is fill. Let's draw this with 0 to 55, 0, for example, like with a green color, or we can do it red, like whatever you like to do. No stroke. And we can say here also draw an ellipse, and saying a key point at 0 position, that is the x position of each key point, and key point at 1, that is the y coordinate of the key point, and 10 and 10. So basically it will draw a 10 by 10 pixels green circle for each key point. And this is very important because we will need this. So let's see if this actually works. So if we do that, just let me show the window that I want. So let me adjust that. There we go. Let's just let me configure this. This smaller. So yeah. So you see now, I'm with a different camera now. So you see how it is actually like showing my key points. It's doing it with like relatively like good confidence. So if I approach the camera, you can see that it's rendering those key points. And this is very important again, because okay, our model is working, but also this is good to visualize that we are getting 21 in this case 21 key points. I'm gonna keep this like this so it doesn't interfere. Actually, let me do something so you can see it. I'm just gonna put it on my other screen so it doesn't interfere with my usual things. Alright, so as I was saying, you see that here we have 21 key points, and this is interesting because we want to actually like recognizing this in a more generic way, it poses some difficulty. So for example, if I want to input the positions of each key point, right, in our screen, that is kind of like you're adding like 1 degree of difficulty to the hand recognition. Why is that? Because for example, if I put my hand here and if I do the training here or here or here, I mean, you're kind of generalizing and you're saying that, oh yes, I will predict the gestures according to not only like the position of the key points or the gestures that I'm doing, if I'm doing like this, for example, or something like this, but also that will be tied to the position of the screen, right? And that's something that we might not want. So we need to do something else to actually perform this in a proper way. So to do that, just let me get rid of the visualization of this. We will do something that is actually quite interesting from my point of view. So now that we have this working, we need to start saying, okay, how are we going to perform that classification that we want? And in this case, we can do a couple of things, right? So we can, for example, create another model that we will call brain, as usually they call it. And for the examples of ML5, we will say like, we will create some sort of like state machine, right? Pretty similar to what Daniel Schiffman did in the hand pose thing. Actually, I'm gonna do it like in a pretty similar way, and I'm thinking that I could borrow from his example. I mean, you can implement this with buttons and things like that, but I think his example, if I remember correctly, it was kind of ugly coded, but I am an ugly coder as well. I'm a terrible programmer, so it doesn't matter. So we will say like waiting. I make things work. So we will also create we will need something, I imagine, like a label, because if you want to train something, classify, for example, a pose, if we're classifying, recognizing gestures, you want to basically couple that with a label, so you get an answer of what actually you're getting. So we will do that. And let's create, but that will for later maybe. Let's create a text that does that. So now that we have everything like hand related here, let's just do that. Hand model stuff. Actually, it's here. Hand model stuff. And here we want an end model stuff, so you know that there is a separation. Oh, I have multiple. We'll use that. So we can do something like, in order to create a model, for example our brain, we need to pass options, right? So those options is just an object that will have like typical things like inputs, and in this case, as I'm planning to do, so for example, if I remember correctly, Dan Schiffman at the Coding Train, he does he trains actually on the positions of each joint of the pose, so he's doing like YMCA and things like that. So he's detecting, I think, like 34 points, because it's 17 key points for a model for the skeleton, I think. So you want to input the X and Y, so he was training just like a long array with 34 values. In this case, we can do the same. We have 21 key points, so we can go up to 42, but what we're going to do is a little bit different approach. We're not going to train based on the positions, but into something else that actually I think it will work very well, because I thought a little bit about this. So we will do outputs, and our outputs, you can set it to whatever you want. We will say like, we will just classify like 3 gestures for now. Our task is a classification task, and we want to debug for sure, right? We want to see what is going on, not the big debug. We will set this to true. And once we have our options, again, let me format the code so it looks like tidy, we can create our brain. So we will say like brain is equal to ML5, that neural network. We will pass the options, and also we can call again to model ready. Actually, I fixed this. I had it as video ready. It's model ready. And that's it for our brain. So now we need to implement the classification part. And if I remember what Schiffman did, he had like a couple of key press events detecting. He was detecting a couple of key press events. That actually is very useful. You can use buttons, but we will use key press. If you want to modify this for buttons, it's great. Leave like some comments on how you do it, if you run into any problems. So let's do that actually, right? So we will implement function key press, I'm a little dyslexic today, like writing not very good. I need my morning coffee for sure. So, we can do two things. Now that we're writing this, I imagine that we will need, as Schiffman did, a first function for example, if you press a key, I remember, for example, if you press A, that was going to be your label, but that will also trigger two things. A preparation time, so that you can adjust your gesture, and also a collection time. So let's implement that first, and then we will try to modify it because we want to maybe implement also here the possibility of training. So we can say like label, because we have our label, right? We have our label declared here. Label will be equal to key, like whatever key you press. We can do console.log label, so we can know what the current label is. Actually, we can do something a little bit more elaborate. So we get like human readable messages, creating labels for, no, creating samples, sorry, for label, and here we just do this. So this will plot like a human readable message that we are creating the labels for whatever, or creating samples. Or actually, no, let's do this. Creating class. Yeah, that makes more sense because we're going to create the class. So we will say like set timeout. So we want to, again, based on this is Schiffman's ugly but effective function. So we will do this Schiffman's ugly but nice and effective loop, right, or function or whatever. We will say function, and we will create this, we will say something like console.log, and here we can put this message, creating samples, or gathering samples, collecting samples will be like the collecting samples for blah blah blah, label something, and we want to, because we're creating a state machine, we want to change this to collecting, right? So we are collecting samples, and then we want to create another timeout, and this timeout, what will do, it will basically we will change the state to collecting, and once we change this, we also want to set a preparation time. So, or actually after this we want to say, I will explain in a second. So you'll say here, not collecting more samples, and we want to change back the state to waiting. Alright, so now that we have this, let me format the code in a better way. This is parenthesis nightmare. We will set this to 10 seconds, and here we can say, let me think, oh yeah, comma and parenthesis, and here we can do like, we can give like 3 seconds. Remember, these are milliseconds, so we can say that this is, let me erase that parenthesis, we don't need that. Are we okay with the parenthesis? Probably I'm missing one. No, we're okay. So what we will do, we will press a key, right? And after we press a key, the program will wait for 3 seconds, and after those 3 seconds it will start collecting samples because it will change the state to collecting, and we will do something with that. And then after 10 seconds of collecting samples, that is a good amount of time to collect your samples, it will stop doing that and it will basically return to like normal state, so we won't collect things anymore. But now that we're here, let's just implement something else. We can say like if, for example, the key press is equal to T for training, we will also start training this thing. We could add one that is it's predicting, but we will add that automatically. I think it's better, so we don't add more stuff. And this autocomplete it drives me a little bit crazy sometimes. So if we press that key, we will enter training mode. And let me close this here and format this nicely. So this is our key press, right? If we press T, we train. Else, if we press like any key, right, we will create a label, and at the same time we will start, after 3 seconds of adjustment, so we can get the gesture right, we will start collecting samples. Very Schiffman type of implementation. So what we want to do actually is that when we now here in the draw hand, we can do something like, again, probably this is not the best way, but whatever. I'm confident that it will work. A state in the draw hand function, if state is collecting, we will call a function that we can call like add sample, right? So basically, if we enter that state after 3 seconds, we can still doing this, but we will call the add sample. And maybe we want to repeat the same thing, but that's okay. So let's create that function, right? Function add sample, and add sample will do. We want to again add the samples to our brain, so we will need a target label, and we need to do something as simple as this. We need to basically put the label as an array. So we have our label. That label will be the variable. When we press the key, we will assign a value to that label, and we can do also. Let's create something like, I don't know, training inputs, and this will be an empty array. And for this, I will reuse this code here. I think this is the best way, but we don't need to draw anything. We just need to get or format our data in the right way. And to do that, and this is actually I think a nice thing, because I'm pretty confident that this will work better than the way that, for example, Schiffman did it for pose recognition, because you're again like detecting your landmarks for your skeleton, for those basically talk like on a screen space position type of thing. So we can modify this in a very nice way to do things in like a little bit different, that I'm and with less units, right? Inputting like less units, so that means that it will work faster, I think. And it's based basically on distances, right? So if you look at my hand now, right, what this will calculate are all the key points, but also it will calculate a bounding box. And what we want, that from that bounding box, we want to get more or less, right, a centroid for the hand. And basically that centroid, it could be whatever point. Actually, you can use one of the other key points, but what we want to do is to measure the distances of each key point to that reference point. Or it could be like a point on the screen, but in this case we will use this because I think it's a nice way to do it. And I'm thinking, and when I thought about this and I sketched a little bit on how to implement it, I think this could work in a better way. So basically now we're dealing with like local, like hand local coordinates instead of screen coordinates to actually do the prediction. So let's do that. We will say like let key point, let's x, let's create a coordinate x, key point at 0, that is the x value, right? And let y, that is key point at 1, so that is the y value. And now we need to perform like some sort of like a little bit of vector operation. So to do that, let's just calculate the centroid of the hand's bounding box. So we will do bounding box. So we can say something like let beg1 and beg1 will be equal to, in this case we'll say like prediction bounding box, and bounding box has one parameter that is the bottom right. If you look at the documentation of this model, I'm familiar with this model because I implemented it like in TensorFlow.js, for example. And if you look at the documentation, you will see that the bounding box has is defined by the again, like the bounding box bottom right. So we will create a vector. I don't think that we need this. For me, it's a little bit it helps me, to understand how this might work, because I come from a Rhino CAD background. So the first coordinate of the vector will be the bottom right x, and the bottom right y will be this. So this is creating our first vector. Let's create a second vector. So I will just copy this, and we can call it vector 2, and in this case is top left instead of bottom right. These are this 2 defines that bounding box. So to actually calculate the centroid, or like the middle point of that, we can say this is just like a typical like let's actually create function. We can do function midpoint. Let's just create a function that does that calculation for us. And for this we need x1, x2, y1, y2 as parameters. So this function will say like return let's return an array, in an array the 2 values. So we will say so if you want to find the middle point between 2 vectors, you know that is like you add the vectors and then you divide by 2. So in this case we can do x1 plus x2 divided by 2, and the second value will be the same thing, like y1 plus y2 divided by 2. This will work. Yeah, so now if we want to calculate the centroid, we just pass those like the corresponding value to this. So we'll say like let centroid will be equal to midpoint, and in this case we want to pass beg1 that x actually let's do this in a more organized way. So this is x2, x1, y1, x2, y2. Yeah, so we get this in order. So we will pass the beg vector 1 x and y, and comma the vector 2 x vector 2 and y. Is this correct? So we don't get a vec 1 x, y, vec 2 x and y. Yeah, this is correct. This should work. We will test everything in a minute. I just want to go with the code and try to finish this. Because we're already 35 minutes, so I don't want to take much longer. So now we calculate the distances from each point, from each key point to the to that reference point. That is the centroid. That it will be variable, I think. Yeah, it will be variable according to the scale, but probably not, because we will normalize this, so that those will be consistent with the gesture. So I think, yeah, this will work. Anyway, so let's do this. If it doesn't work, whatever, I will try to modify this. It's a good exercise, at least think about this, on how to basically like chain two models. We are chaining two models into one, and that is always interesting for me. I like doing that type of things to make things like work, so they don't die and just like pressing play and just like detecting your hand and that's it and blah blah blah. It's interesting to go beyond that. So let's use the distance function from P5. Basically it takes like two values again, like x, y, and centroid. We can take the centroid x value and centroid y value, because x is at 0 and y is at 1. And now this is the interesting part. We want to basically like put all the values together in one array to then input that. But we will do something that is not very... I had problems in the past doing these things, so I will do a manual normalization. Not use the ML5, because I also saw in the Git that there were some problems, and I ran into some problems that it was not like converging very well when I was using their method. So I don't know. Probably there is a way to do this in a better way. So we want to express those distances normalized in terms of, yeah, so actually it doesn't matter if the hand is like bigger or not. We will express that in terms of in a range between 0 and 1, normalized values. So now we add the distances values to our array, and we will select training inputs that push, and here we will do just like a manual normalization. So we will say 1.0 divided by the distance. Simple. And now that we have that, the only thing that we need to do next is just, let's say, console.log just like a little bit message, so we know that we're adding the samples. To class, and here we can say label. Yeah, here we can put this. So for each cycle we will be adding these classes, and now we add that data to our brain. And to do that, we will say like brain.add data, training inputs, and target. Remember that the target is an array with the label. Actually, it's target label. And I think with that we're golden with the training samples. So let's finish a couple of things. So now that we have the collection like supposedly like working, we won't test that now. Actually, we could. Let's just save this, open the live server, and let me turn on this. And okay, this is still working, so let me move it a little bit on the screen so it looks bigger. Let's open the it's detecting my face as a, that is a little bit weird. So we need to establish also, we can add a threshold for the confidence. So let's see if this actually, like the part of getting samples work. So if I, for example, press 1, train is not defined. Okay, train is not defined. So let's just, that is weird because we should not, oh, because it's reading from here. Okay, let's just put the train function here. And for now it's just console that log hi. Just a placeholder to see that this is not creating any problems. Okay, now you see this, right? My hand, if I press 1, set hi, and it should, something is wrong here. Let's just fix it. Let me check that function. Oh, I think this was my mistake. I forgot to put the else statement here. So let me just format the code. Yeah, I forgot to put an else statement here. So let me save this. Go back to my implementation here. Let me just put it on the screen for you. So now, detecting my hand. Yeah, there's always something that you, the model's ready. Hi. Should wait for 3 seconds. It didn't print the model though. Let me check again what might be the problem. Move this to the side. Where's my, if key equals t, you will train, else label key. That is okay. Function, timeout, console log, waiting. Everything should be good. Oh, oof. JavaScript. And also me, silly. I was like, key is equal to t. So yeah, of course it was not going to work. I was missing just like one equal sign. So now, if I move this here, sorry about that. Again, morning coffee is like needed. If I did this and if I press 1, yeah, creating class 1, should wait for 3 seconds and it's adding the samples. But for some reason, my visualization disappeared. But now it's not collecting more samples, but now we see this again. That's fine. So we can do this, creating class 2. Yeah, it disappeared again. I will check that. And now we can do, for example, this. I just created class 4. It's just like a number, that doesn't matter. So we want to check a couple of things. Alright, so now collecting more samples, so it will go here to brain. There is one part where it is data. I think, I don't remember where actually it was the data collected. Well, it doesn't matter, but we can see that at some point here, no, these are the options. I don't remember where it is. The it should be in data, where we actually see if we got the samples or not. anyway, you can see here the information about the labels and stuff. We will check this later. It doesn't matter really. So let's do. Oh, actually, let me check one more thing. And for some reason it's not showing my camera. Okay, now it is. Yeah. That typical error. Yeah, everything is working. So let me just get rid of that. Oh yeah, now checking the code. Actually, I don't need this else and this draw hand statement because we want to just enter, and we want to keep drawing things. So that's fine. So okay, we got our samples. Okay, we didn't get any error. Now we need to actually train our model, and then we will do the classification. So probably will be like in an hour video. That's fine. So let's implement the training. The trainings function that we have here. We need to specify a couple of things. So for example, the training options. How many epochs, for example, we saw this in class, and also like the batch size, like how many data batches of data we're feeding into our network. We will say like const training options. This will be equal to, we can say epochs equal to 100, and the batch size, let's do 64. We can do 32 if you see that your training is like getting, like, I don't know, not performing very well. That's fine. And now we actually train passing those options. So we train our model. We train coffee. Alright, so now that we have this, we can say brain.train, and we will pass those training options, and then we can add a callback function, finish training, because with finish training we will do a couple of things. So we can say like function finish training and dot log model trained. We could add like some and plot some other stuff, but here after we train we will start classifying immediately. We won't wait or add a button. So basically we start classifying, and also we will do something that I sketched, because again I had some problems before, so probably this is someone that is like a very good programmer. I am not. Will say like, no, this is not that you do it because JavaScript allows you to do this magic blah blah blah. I will do it this way because I know, I have the hunch that it will work, because it gave me errors before. So I will actually add here another parameter that will be called is predicting, and we will start it as false. So basically it's not predicting. So when we finish our training, we will say is predicting equal to not is predicting. So this will change it to true, and this will set a condition for the classification. But let's write first the classification function. How can we do this? According to my early morning sketch, the way that I will do it, because I don't want to think about implementing another function, I will do it this way. Inputs, again, it could be reduced to, yeah, like a computer scientist or an engineer will basically say that I'm some sort of heretic for doing this, because if you're repeating your code, it's basically, you know, that something is wrong. That's fine. That's fine. I don't want to think more. It's early in the morning, so I will give you, like, I don't know, tonight or after I give you the video, the clean, better version of this. So I want to copy actually all of this. Yeah, I can clean it later. So I will do a couple of modifications here. So we will have a array that we will call inputs. We will do the same thing of just like going over our predictions, getting the key points, calculating the distances, calculating basically the centroid and the distances to the centroid. But here, instead of saying training inputs, we'll just call this inputs. Do the same manual normalization, and here we will just leave it that way. So you understand, we're just doing the same process of getting basically the format in the same way that we were putting it as samples in our network. This is why I'm repeating this code, so we can clean it and make it just like one nice function. That's fine. But now that we have we can do something. So we can say that if inputs.length it's over 20. So we could get, sometimes it depends on the light or things like that, we might get like some errors, some null value that will basically like screw all of our detection. I've seen that. Probably I just want to make sure that this works. We can say that if we have like enough data, like more than 20 points, meaning that 21, that is the maximum that we can get from this, we can just do brain that classify, and we will pass the inputs, and once we classify, we can add, so for example, like handle, this is usually how they do it, results, handle results. They call it like God results or things like that. So that is fine. So we add that callback function, so let's implement that function, handle results, and this will take the error and the result. So let's remember how was this done. If error, no, if error, we can say console.log error, no, console.error, not .log, error, yeah, this is the way we do it, and then return, and then we can say console log, and we can just get the prediction. So in this case, you know that every time that we predict something, so for example, okay, this is the gesture that I want to classify, right, or recognize, because we will have 3 gestures in this case in the sample to classify. Always the result at 0 index, it will be the one with the highest score, with the highest probability. So this is why we're only plotting that one. But also, let's do something. Let's add a label. Predicted label, actually. Predicted label. So here, for example, we can do that. Predicted label. It's just create paragraph, create p, and we will call this label or prediction, whatever, right? This basically will be a text thing, and we want to actually just let me I think I have it in some other, yeah, we'll take it from this example. Where is this? Oh, got lost. We were in the handle results. We can also do this. Predicted label. Yeah. So this is like you will find this line of code everywhere in ML5 when you're doing predictions, right? So basically, we will get that predicted label text, and we will change it to the label, so it shows the label that is predicting, and also the confidence. So we see that it's 90 or 80% sure that our model is this or not. We have the finished training implemented. We have the train implemented. So okay, yeah, this is the thing. Usually in handle results, actually let's try that. Actually, you did this, so you classify again. Let's see how this works. If not, we will implement something else. So we have our model. Let's just, yeah, we see the label here. So let me turn this on. Yeah, you see the camera now. You see the app. So let's just start classifying this thing. Just adding the samples. So it's 10 seconds of samples. So again, because we're dealing with like local coordinates and distances, we don't care about the position of the hand according to like relative to the screen. So we will do now this as a second. So this is our second class, and something that is like kind of different. So for example, like this. You see it waits for 3 seconds so you get the gesture right, because sometimes it interferes with the face, so you don't want funny things happening. So let's see if this actually trains. It doesn't, because it cannot read properties of null. So let's see what's that. Switch to lowercase. Ooh. What is this error? Let's see what this error is. Alright, so I was having one error. That was like something here in the key press. So yeah, actually I realized also that for some reason, if I do the typical thing of like adding a loop here and the classify, it breaks. So for now, so I know that this will work, we will just say something like because once we start we stop training, we call the finish training, and we said like is predicting, it goes to true. We can handle that part of calling the classification, for example in the draw function. So we can say if is predicting, so basically if that's true, we will just call classify. For some reason after a while it was just stopping if I was not using this. So I paused the recording for 5 minutes to check why. Now that I'm sure that everything works okay. So let's just open the live server. You see my screen. Oh, that's kind of weird. Let's see here in the more tools, developer tools. Is this working? Let's just reload. Yeah, now it's working. Alright, we see my hand, so let's do the actual training. Let's see if this works actually. So let's just start getting samples. We press the 1, so you see in the console it's getting the samples. Alright, I'm not, let me just move slightly my hand like this. Okay, now let's do a second gesture. So this is why I need to adjust it, like making a fist. It's getting the samples. It's a little bit noisy because of the light, so I'm gonna get this here. Right, and now let's do, I don't know, like, let's do this third. Alright, and if I press T, you see that the network is actually performing the classification. Sorry, the training. So it will run through 100 epochs. You see that our error is going down. It's interesting that sometimes it goes up because probably, I mean, the data is a little bit noisy, but it should give us a good fair amount. Oh, so it stopped. So let's see. Yeah, label 1. It didn't train very well, so probably we need to increase the amount of epochs or more samples. So it's like 70% sure that that's the label 2. It works. So if you can see it on the screen. And label 3, class 3. So you see now, more or less, yeah, probably we need to increase like better samples or train it better. But it works most of the case. Probably my data is a little bit noisy. So yeah. So there you go. You have the implementation now for your assignment if you want to do it, because some of you wanted to do this actually with hand gesture with more detail, not with the body, the drawing machine assignment. So do this. You can again change this to train it with for more epochs or things like that, in also like in better light conditions, so you get like better detections. But this is working. So I hope you liked it. Subscribe to the channel if you have time, so you can get more news about. I'm trying to upload content regularly, hopefully like in a weekly basis, so you can learn all of these fantastic things. Like sharing is caring. So see you till next time.